Good morning. Lesson 1-1. So this is Reveal Math, Course 1, Volume 1, which just means the first part of 6th grade. Our I can statement will be at the beginning of all our lessons. I can show a ratio relationship between two quantities using different representations and describe the relationship using correct mathematical language. Mathematical language we like to call mathlish. So understanding ratios are really just a comparison between two or more things, and there's a couple ways we can write them. This is a table. Sometimes we'd call it a T-chart. So a T-chart would be written kind of like this, and we'd have the ingredient over here and the number of cups over here. And so we'd have lemon juice 2, simple syrup 1, and water 7. And T-chart because it's a T. This is a table, T-chart. We use them interchangeably. Really, I think the only difference is a table just has a box around the outside. And then this is a bar diagram. I won't generally show you the bar diagram way. If you do want to know that, please contact me individually and we can go through that. This way is going to be more help as you get older. Let's skip over here to the example 1. And a lot of examples we'll deal with ratios have to do with paint because you can mix them to make different shades. But also we do a lot of ratio things with cooking. So recipes are a great way to understand ratios. So in this example, Pedro mixed 2 sample containers of blue paint with 3 sample containers of yellow paint. So if we were going to write that as a ratio, blue to yellow would be 2 to 3. Or blue to yellow would be 2 to 3. Or blue to yellow would be 2 to 3. And this is the representation I'm really going to push towards as we get later on in the module, because this is what we're going to use when we go to fractions. And ratios and fractions super closely related. So anyway, Pedro mixed these containers of paint to create his favorite shade of green. Pedro realized he did not have enough paint, so he added 2 more sample colors to each color. He added. So let's move this down here and say blue, yellow was 2 to 3. And then he added 2. So 2 plus 2 is 4. 3 plus 2 is 5. Will the new mixture result in the same shade of green? And justify your response. So here's how we would justify this. That yes, it works, or no, it doesn't. We want to use a factor. So a factor is something you multiply by. What do we multiply 2 by to get to 4? We multiply by 2. So what do we have to do to this side to keep them equal? To keep them equal, you have to do the same thing to both sides. So we would have to multiply by 2. If you're new here, an elevated dot means to multiply. Often we will not use an X to mean multiply because it has different meanings later. And 3 times 2 is 6. And that's not a 6. So then we would say no, comma, not equal. Because, and here's the easy answer, you cannot add to create equivalent ratios. You can't add. Answer in a box. I should also mention, because this is the first lesson we're going through together, if I write, you write. So if you're doing this at home or at school because you missed a day or you just want to try to figure it out, when I write, you should be writing as well. It's a good way to learn. So let's do a check. A recipe for rice calls for 6 cups of water. I feel like we could make a table. Water, 6 cups. And 3 cups of uncooked rice. Rice, 3 cups. Trinity only has 2 cups of uncooked rice. Well, where do we know to put the 2? Well, because we label our table, then we know that that's uncooked rice, so it should go here. If you don't label it, often you don't know where to put the numbers and you get lost and it's super frustrating. So label your things, it helps. She reasons that because she subtracted 1 cup of rice, 3 to 2, subtract 1, she needs to use a total of 6 minus 1, or 5 cups of water. She says this should be 5 because here she subtracted 1. Is she correct? No. Well, why? If you cannot add to create, you cannot subtract to create an equivalent ratio. Can't. You can, though, multiply, and you can divide. I'm going to leave this learning part, all this learning part, blank. I'm not going to write on it. If you need to go back through something, this is great to go through on your own. I'm not going to spend the time to do it here, but it really talks you through everything you need. Let's go to the check. The example is the same way. So let's skip down here to the check. Refer to the table in example 2, and we'll scroll up to that in here a second. If the large vase has a total of 36 flowers, how many are carnations? Okay, so we're talking about total flowers and carnations. Okay, so the small vase has 6 carnations and a total of how many flowers? Well, 6 plus 4 is 10, plus 2 is 12. Okay, so the small vase has a total of 12 and 6 of them are carnations. So before they even ask us a question like, what relationship do you see here or this direction? So let's go from 12 to 6. Well, 12 to 6 is dividing by 2, right? And if we were going 6 to 12, we'd be timesing by 2. So let's see if their large vase, if the large vase has a total of 36, then how many carnations should we have? You can follow these same rules. 12 divided by 2 will give us our unknown thing. And I know to go this way because what I know to what I don't know, right, is important. So 12 to 6, we divide by 2. 36 divided by 2, 1, you can use your calculator, or 2, you could just do the work longhand. It's not super hard. 2 goes into 3 1 time. 2 goes into 16 8 times. There would be 18 carnations. Carnations is a type of flower if you're curious. Okay, find the relationship. Apply the relationship. We found we could divide by 2 here, so we should divide by 2 here. Let's go over to example 3. Similarly, you can look through example 3 and do all of that. I'm going to skip down here to the check. This is all laid out for you and they talk you through it. This part they don't, so that's why I'll go through that with you so you have an extra example. Refer to the table in example 3. If the large box contains 9 chocolate muffins, how many cinnamon muffins are in the box? So we're comparing chocolate muffins to cinnamon muffins. Chocolate, oh, and they both start with C. That makes it fun. Chocolate to cinnamon. Okay, and we're going to have a small box and a large box. And if you label all of this stuff, if you will just label these before you even put numbers in, you're going to know where to put the numbers and you're going to be a lot happier. So back up here to the small box, they have 1 cinnamon and 3 chocolate. So I put that down in our table below. 1 cinnamon, 3 chocolate. And now back to the questions information. If the large box contains 9 chocolate muffins, chocolate large 9. How many will be cinnamon? So find your relationship. Here's something I know. Here's what I don't know. So this relationship here would be ideal. So look up at our known information. How can you get from 3 to 1? Remember, you can't add or subtract. How do you get from 3 to 1? Yeah, divide by 3. So down here, we would also divide by 3. I'm going to show you another way in a minute, but let's just stay with this way. 9 divided by 3 is, 3. 3 cinnamon. Are these donuts or cookies? Muffins. Oh, not even donuts or cookies. Now, here's the second way. If you're like, You can also do a vertical relationship. So we knew this one, but we didn't know that. So we could go from 3 to 9. How do you get from 3 to 9? Times by 3. What's 1 times 3? It's 3. Worked both ways. Yay for us. Okay, so that's your lesson 1-1. And your practice problems will follow, or your practice problems will be on McGraw Hill. Good luck.